Let's say that if 785.5 joules of energy is added to 3.8, and I'm just making this stuff up, I hope I don't go through a transition here, 85 grams of water at 5.0 degrees C, what will the temperature become? Okay, when you get all that written down, we're going to see how that fits into our graph so we can figure out what equations we need. Okay? (785.5 joules of energy added to 3.85 grams of water at 5 degrees C. What will the temperature become? Okay? Alright, so let's take a look at the graph. Raise my camera back up a bit so we can see what we're doing here. Alright? Let's look at this graph. And we've got to figure out what part of the graph we're in. Okay? We're at 5 degrees C. What part of the graph are we in? Right. This is 5 degrees. This is between 0 and 100. And so that means we're in this liquid state right here. So this is the equation we need, and this is the CP we need. And at this point, once you identify that, it becomes plug and chug dimensional analysis. Okay? Kind of, sort of. All right? Let's plug and chug. We know we have this amount of energy, so which one of these variables is that amount of energy? No, sir. This is joules of energy. That's the change in temperature. Where's the energy in this equation? Guys, it's right here. It says energy right here. What is it? Q. All right. So let's write our equation down first. Here's Q. And then we've got mass times that CP. What? No, that means something else. Okay? And then times the change in temperature. Okay? That's our equation. I just wrote down the equation, right? And so what can we plug in there? Let's see. In the question we got 785.5 joules. That goes right here. 785.5 joules. That goes right there for Q, right? What's M? Yeah, that's the mass. I hope you kind of know that from your physical science class. So 3.85 grams, that's the mass. And what's the CP?
5 degrees.
No, sir. Look on your where we wrote all that notes, those notes down. What's the CP?
4.18.
Okay. 4.18 joules over degrees C and over grams, and that goes in for the CP. All right. What we don't have is the change in temperature. We just have a beginning temperature, don't we? All right. So what we want to find out first is what is the change in temperature. Okay? Yep. Do we have everything we need? Yeah, we do. If we have an equation that has 4 values in it, 4 variables in it, and we have 3 of the 4, you can find the 4th, right? All right, let's do the math then. Huh? 7, 8, 5.5 joules equals 3.85 grams times 4.18 joules over degrees C and over grams. And then that's times that delta T we don't have yet. We're trying to find that first. How do we get delta T by itself? You divide both sides by this, right? These two things. Okay? No, you don't know that? That's how you get rid. That's how you move 3.85 to the other side to get this by itself. No, this is multiplication. You can't undo multiplication with subtraction. You have to undo multiplication with division. You understand what he's saying? Anybody else feeling lost right now? Who's feeling lost? Okay. All right. Well, here's how I would like to teach it for you. I'd like you to get in the habit of doing it this way because it's going to come back again when we get to gas laws. Okay. I'm going to shrink this down just a little bit so I got more room on the outside. I'm going to put this equation kind of in the middle of the paper so I have some room on the outside. Okay? In fact, I really ought to have a smaller pen, but let's use this one anyway. So 785.5 joules. I'm going to end up putting it over 1. Oh, that should be equals, not some other number thing there. 3.85 grams, I'll put it over 1. 4.18 joules per degree C per gram times delta T over 1. Okay, now there's a reason why I put all these over 1, because here's how I want to divide. I'm just going to make a fraction with this flipped and a fraction with this flipped. Okay? And I'm going to multiply. It's the same thing as dividing. You got it. It's called a reciprocal. Very good. Huh? Okay, well, some people haven't gotten all that language down. So we're going to flip this one. 1 over 3.85 grams. And this one gets flipped here. Degree C times grams goes on the top then. And the 4.18 joules goes on the bottom. All right, now, we originally had this. Here's what you need to know. I can't just do that to one side. If I do it to this side, you've got to do it to the other. All right, this is the what's fair for the goose is fair for the gander system. Y'all never heard that, did you? Oh, well, never mind then. Okay. Basically, if you do it to one side of the equation, you've got to do it to the other. Y'all remember that? All right. So if I do it to this side, I've got to do it to this side. So let's plug those in over here on this other side, too. This one is also over here, 1 over 3.85 grams. And this is going to be put over here, too. You can't do it to just one side. You've got to do it to both. You've got to be fair. Okay? But here's why all that is really neat and where the dimensional analysis starts to come into play. How do we simplify this equation now? Look at all the stuff we can do. Yeah. This and this completely cancel, don't they? This and this completely cancel. This and this completely cancel. And we have delta T all by its lonely self. It's called isolating the unknown. Well, that's what I call it anyway. Some math teachers might call it something different. All right? And maybe my isolating the unknown term goes back, however many years it was I took math at high school. Maybe they don't use that term anymore. I don't know. Over on this side, we can still simplify. What can we simplify on this side? But we can simplify the units of measurement. Look at the units of measurement. Grams can cancel. Joules can cancel. And all that's left is units of degree C. And degree C is a unit that would handle our quest for finding out what the change in temperature is, because temperature is measured in degree C. Right? Okay? So all we got to do is do the math here. All right? You take this number on the top, divide by this number, hit equals, and then take that answer and divide by this number. Okay? So let me walk you through that, because some of you probably aren't aware of how that works. We're going to take what's on the top here, 785.5, 785.5. Well, I need to delete the rest of that stuff here. All right, now 785.5. Whoop, I did 0.8. Well, I don't want to do that. 0.5. Then I'm going to divide by this on the bottom, divided by 3.85 on the bottom. Hit enter. Then I'm going to divide by the other thing on the bottom, 4.18. See what I'm doing? All right, I took the first 785.5 and divided by the 3.85. Then I hit enter and got this big old number here. Then I took that number and divided by 4.18. Okay? And when I enter, that's the value I'm looking for here for the change in temperature. Okay, good. So I get the whole answer here is 48.81004163. And what units of measurement are left? That's okay. Your calculator may not go to the same number of digits mine does. It doesn't matter. Just show me all the digits your calculator goes to. Now, if your calculator is shutting it down at only a couple of digits or 3 digits past the decimal, you need to reset up your calculator so it'll show you all the decimal places. Okay? Because you can set them up so they only give you 5 decimal places or something. We want a floating decimal place. That's what we want. Okay? So it's degrees C equals a change in temperature. Okay? Well, what temperature did we start at? 5 degrees. And if we added energy, let's go back to our graph. If we're adding energy, and that's what the question says, we're going to add, this amount of energy is added. Okay, so the energy we're increasing down here. Okay? Adding heat energy. Got it? So we're going in this direction, so the temperature must also be, if we're going in this direction here, the temperature has to also go up, right? And it must be going up by this amount. It's still a liquid. Let's round off first, and we'll get there. How many digits do we need in this answer? 3. Where do I start underlining? The one that's right after the 8, right here. Round off to 48.8 degrees C is the change in temperature. But we want the temperature itself, right? The question says, what will the new temperature be? What will the temperature become? Since we're adding heat, we're going up. So we just add that number to what we started with. Does that make sense? So the change in the temperature is going to become T, the final temperature, is actually going to be 5.0 degrees C plus 48.8 degrees C. How do we figure out what significant digits we need in this answer? Well, remember you got to put them vertically. 5.0 degrees C, 48.8 degrees C, and add them up. And if we do that, we can see there's no empty spaces to the right, so we don't really have to round off anything. But if you don't put them vertically, you won't know that. Because that's the rule for figuring out significant digits when you're adding and subtracting. Okay? Well, now you can plug it in the calculator, but this is the way you figure out if you got to round off. Okay? If you don't round off properly, you won't get the right answer. Which reminds me, I haven't taken up yesterday's homework. So 53.8 degrees C, right? That's the final temperature. T sub F is temperature final. So there's our final answer. Our final temperature is going to be 53.8 degrees C, assuming there was no transfer of that heat energy to the surroundings. It was perfectly insulated.